Hi everyone, welcome to a new video. This is the section 7.4. As we already know, we are going to start calculating the intervals of confidence inside of a sample of a population. But now, what if this sample is have less than sample of less than 40 than 40 for individuals? So if we have this case, we can use this formula. We can use T equal to the mean sample minus the mean of the population divided by the standard deviation over the square root of n. And what is the main difference about this? First, we have the degrees of freedom. Degrees of freedom. In the text called as n minus 1, and some of the texts call it the DOF, DOF. And not all the distribution I want to be simple. So not all going to be simple. And why simple? Simple is because the population could have different degrees of freedom, or could if you have more than 40 degrees of freedom, you can use the other videos to solve this. But if you have this, if we made a chart where we have our limits and we have 1 degree of freedom, the chart is going to look something like this, because we only have 1 degree of freedom. But if we have 2 degrees of freedoms, the chart is going to see almost the same. But if we have 40 degrees of freedom, or more than 40 degrees of freedoms, we start going to another color, I'm sorry. We are going to start seeing the form of the graph that we are used to. So this is 40. This is, I think we say 1 degree of freedom. And this is 2 degrees of freedom. So now, if we want to have a sample of a population that only have 1, 2, 4, 5, 6, 7, 8, 9, 10 degrees of freedom, we can use this procedure, these steps. Okay. So if we want a 95%, we have to divide 5 over 2 to have this 2.5%. If we change it to decimals, we have T equal to 0.05 over 2 with a 6 of degree of freedom. If you are going to know which is the degree of freedom by subtracting 1 from n, that is the number of values in the sample. And this formula is going to be repeated in the lower and the upper position. So it's T 0.05 is alpha over 2, and the DOF n minus 1, and the same for the lower position over 2 and minus 1. Okay, so the formula, solving for the main of population, we have the main of the population minus plus minus T alpha over 2 and the degrees of freedom, the DOF, multiplied by standard deviation, the square divided by the square root of n. Now, how are we going to calculate the confidence values? Well, with this same formula, we can do an example. This is an example for the book, so if you want to check it out, it's in the book, section 7.4. No, I'm sorry, 7.3. This is the 7.3. I'm so sorry. Now, example. We have a sample with with some numbers. This is going to be a sample of 10 numbers: 21.3, 22.8, 70.0, 29.8, 21.0, 25.5, 16.0, 20.9, and 19.5. This is going to be our sample. These numbers are going to indicate us what is the the characteristics of our analysis. So what we need to know, if we use this formula right here, oh, I don't want that. I'm sorry. If we want this one, if I copy this and use it right here, we kind of notice that we need some values that we don't have. We can calculate it, but to make it easier, I have it right here. The mean of the population is 21.9. The mean, as we know from back lectures, the mean of the population is not a value that we can use to understand what is the continuous, or to understand what is going on with the sample. The mean is like in the middle, like you don't, it didn't represent uh, all the values. It's only a little taste of all the sample. So we need to know the intervals, to know with a percentage of truth, if we can say like that, where is going to be our value. If we take a value from this sample, it could be near the mean, but it's not going to be that. So what is the 95% of the of the opportunity to have a what is going to be the range of 99 this 95%? So let me get it. So the mean of the population, then the standard deviation, that is 4.134. The value of the distribution, that is going to be 0.025. And the degrees of freedom, is going to be n minus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is equal to 10 minus 1 equal to 9. And using this formula right here, we have that the result is going to be 2.26. Now, the confidence intervals, I'm sorry, no, this is not the answer. This is the answer from the TOEFL, 2.26. Now, using the formula, we have an interval of 18.94 and 24.86. So the 95% of our values is going to be inside of this interval. This is our confidence interval. But what happened if we want to add another number, or we want to have a better interval of confidence? This confidence is going from 18 to 24. What if we want to make it larger? What if we need to emphasize in a bigger interval, a confidence interval? What if our experiments, the value that we need to know is not inside of this confidence? So this confidence interval. So we can calculate a new confidence interval using the variance of the sample. The variance of the sample, multiplied by the mean, subtracting the x and plus 1. This, if we solve it, we have that the variance multiplied by the mean plus the variance multiplied by x and minus 1. So this is equal to the standard deviation over n plus the standard deviation at the cube, at the, well, elevated over 2, multiplied by 1 plus 1 over n. If we solve this, we are going to know that this confidence intervals is going to be equal to the mean minus x n plus 1, that is going to be dividing the square root of the standard deviation into the over 2, 1 plus 1 over n, this inside of the square root. So the t, that we already know what is the t, is going to be the mean of x minus x n plus 1 over the square root of s 1 plus 1 over n. Well, now we can use this to have our new confidence interval. So using this formula right here, we can say the new confidence interval. Well, we only have to change one part of the formula. So here we have the mean mass plus minus t multiplied by alpha over 2 and minus 1, that is dov, multiplied by s, this is a change, s multiplied by the square root plus 1 plus 1 over n. Solving this, we have 12.09 and 31.71 equal at 95% as equal as the other example, the other way to do it. So we have this one and this one right here. As we said, we have here in the second formula, and the second way to do it, we have a bigger interval. So now we have numbers from 12 to 31. And in the other one, we have from 18 to 24. Here is a new form to understand the confidence intervals. This is a bigger way to know that this kind of calculations uses more intervals. So that is what we need if our sample is a little bit shorter than we needed. So we can make it bigger with this kind of formula. So this is going to be all for today. Thank you for your time. Have a nice day.